Hi everyone, this is U Science Lab lesson video. In this video, we are going to be looking at how to determine clockwise and anti-clockwise moment. Now consider this. This is a clock having a long arm, and this is the long arm. Then I want to place this force in various directions on the long arm and see which direction the long arm is going to move. Now if I place this and I move it on top of this and I place it on top of this, you will find out that the force is going to push this arm in this direction. So it's going to rotate it in this direction. Now this direction in which it rotates is, as you can see, is in the direction in which the normal clock moves. So this is termed the clockwise moment. So as you can see, this is the clockwise direction, so we refer this as a clockwise moment. Now if we decide to change the direction of the force and put it on the other side, let's see which direction the clock is going to rotate. Now I'm going to take the 20 Newton force again and place it on this side and just push it against this. On pushing against this, you realize that the vector or the arm of the clock will move now in this direction. So this direction is against the normal direction of the clock. So this is termed anti-clockwise movement. So this is the anti-clockwise moment. Again, we can reverse the arm to this other side. We can place this arm here and move it to this other side and check for the directions again. Now let me take the 20 Newton vector and place it in this direction again. Now on placing it in this direction, you will find out that if I press this force against this bar is going to rotate now in this direction. Now again, you can see that the movement of this is also in the normal direction of the clock. So this is also the clockwise direction. So this is also a clockwise moment. Now let's check for the reverse direction. Let's place this force on top here and push it downward and see where the direction will be. Now if I take this vector, the 20 Newton force, and place it on top of this place and apply the force, now you see the direction is in the direction of the arrow. If I apply the force in this direction, this is force, this arm is going to turn in this direction. So you see that the force applied in this direction turns it down. Now if you look at this is direction is what in the anti-clockwise direction. So this is anti-clockwise moment. So this is also anti-clockwise moment. Now in all of this that we have done, you realize that the direction to determine the clockwise or anti-clockwise moment, you always have to look at the direction of the force in respect to a fixed point, this fixed point here. So this is the fixed point where the head of this bar is what? Fixed, is pivoted. So this is the point where it is pivoted and where it is fixed. So you see that it depending on where the force is applied and to which end it is fixed, that is how you determine the clockwise and anti-clockwise moment. Let me just do a duplicate of this and see, and I will explain this better by having this on the other side. So if I have this on this other side, we'll rotate this other way. Okay. Now you can clearly see that in respect to this fixed point and these two arms on the right and on the left, this force, this 20 Newton force here and this one here will produce clockwise moment, because based according to this fixed point, this force will rotate this arm in this direction, and this will also rotate this in this direction, which is the normal clockwise direction. But this and this and this, we tend to move this in this direction, which is anti-clockwise, and this will also move this in this direction, which is counterclockwise, which is also anti-clockwise. But this force moves this in this direction, which is clockwise, and this moves this in this direction, which is also what? Clockwise. Alright, thank you for watching. See you in the comment section.